Right. I mean, is that? I'm not saying no background. Yeah, I mean, they have a charge for it. Like, you can charge for it. He broke him and threatened the whole family. That's right. It's bro, understand. No, I don't even know what happened. I said it's just you. Why is there time stuck so much? Yes, he's right. Yeah, I encourage that. I encourage that. You scared how dare you stick? Why you stick to the license for people? How dare you? That's not crazy, bro. No, it's no, it is very crazy. That's not you get to go home earlier. Skip on a week. I get to go home later. I get here later. I don't get home until like 3. Skip on a week. You have excuse. I'm not making excuses. I just said it.
Okay, if you can turn to page 37. We'll work on two FRQs from 2016.
We have to get most of the two text.
I'm definitely gonna finish it.
Just gonna wait till like the last day.
Bro, you guys like shut the hell up.
President, my product.
I'm like gonna log in, like, take homework on the weekends, so I can just do it. But it might be too late.
Because you got them. That's true, right? You have to deal with that, right?
Okay, that's why I'm getting through the packet together. Nico, how much of that have you not doing work in it?
Like that.
I think so. Have you read?
Oh, this one I really have.
You gotta turn the boats, right? No. This dude can't be serious.
I don't care.
Tell this dude my parents died.
Yeah, so don't say that. I would not do that. You start laughing.
My parents died.
I know you're not making it. I did laugh at my sister. What's her fault? Someone laughing about it first. Laughing about it. So I thought she was joking. Master laughed.
You know what?
And it turns out she actually did.
Yeah.
I haven't studied for my AP bio exam at all.
All right, let's look at this problem here. So page 37. This is non-calculator. We have the inside of the funnel of height 10 inches has a circular cross section as shown in the figure above. At height h, the radius of the funnel is given by r is equal to 1/20th, 3 plus h squared, where h is between 0 and 10. The units r and h are in inches. Find the average value of the radius of the funnel. So we have our radius formula. We're asking for the average value of the radius. So we're going to rely on average value theorem. So that's our part A. Should be pretty straightforward, but we have to work it all out by hand, no calculator. So we got to do all of our integral steps manually here. So I'll write the formula down and then we can adapt it for our problem here. So you can either wait to distribute that 110 through, or you can do it at the beginning. Either way, we just want to make sure we don't forget about that 110. So I'm going to wait. I'm going to do power rule for both these terms. Plug in my upper and lower bounds. The zeros will go away nicely, but just convince yourself every time you see zero, just make sure that you're actually plugging in, and that you're not just always assuming that zero will just wipe everything out. I mean, zero will wipe some things out, but if zero's in the exponent, or if it's inside a set of parentheses with an exponent, sometimes it gets simpler, but doesn't completely wipe out to zero. So this is fine. But if you get it all the way down to cleaned up version, I would say leave your answer unsimplified. I mean, even this is fine here. Well, we definitely might want to make sure that you just make sure you include that 1/10 in your answer. But I wouldn't, spend the time to do common denominator and all that, because once you have your answer, just leave it alone and move on. Okay. Any questions in part A? Okay, part B. Part B is the challenging part with this problem here. Kind of requires us to kind of look outside the box a little bit. It says find the volume of the funnel. Okay, so we have a funnel here. The hint is that this has a circular cross section, meaning that if we were to cut this in half and we open it up, we're going to get circles, circular shapes, if we were to look inside a cross section of it. So if we want to find the volume of this funnel, we have to think about, well, what allows us to create volume of circular cross sections? Do we have a certain formula that allows us to do that? So what volume formulas do we know? Or when we talk about area and volume, we did cross section for semicircles, for rectangles, for squares, but then we also had disk and washer method, right? What do you know about disk and washer method? Or what are the shapes of their cross sections? The rotation is causing what shape to show up? Circle. So there's the hint there. It's either going to be disk or washer method that gets us to our answer. Now, some students were looking at this thinking, oh, they didn't know what to do. So when students took this AP exam, they were telling me that they tried to do a volume of a cone and doing similar triangles. But if you look, this is not a cone, right? That curved shape is not allowing this to be a cone. So I know it kind of looks a little bit like that similar triangle setup, but that's not the case here. So what would you do to allow this to be either disk or washer method? It kind of requires us to kind of look at it from this perspective. Okay, looking at this perspective. So thinking of it as a graph that looks like this. And instead of normally this is our y, sorry, this is our x. right? And this is our y-axis. And if I gave this to you and I told you to rotate it around, then you would say, okay, it's going to obviously be this method. And if I gave you an equation, y is equal to 1/20th 3 plus x squared, that wouldn't feel too difficult, right? Because you would just see, oh, okay, there's my graph, top minus bottom. I'll just do this method. But what's difficult here is that they're not giving it to you in a way that it's easy to see that it's this method. And also, you see the variables. It's sideways, and the variables are not x and are not x and y. So what we really need to do is think of this as our h. H is our independent variable now, and then r is our dependent variable. So it's the same curve, but now it's going to be r is equal to 1/20th 3 plus h squared, which looks a lot less familiar. But I wanted to draw it out this way to make that connection with this, right? Essentially, it's the same as just, we got to adapt to the fact that it's not x and y variables. And, we have to kind of look at it from this perspective and into this perspective. So that does make it really challenging. So now we see that we can just rely on this method, right? After that rotation, there's no gap. So we find our big radius, which is top minus bottom. And the bottom is that h-axis, y-axis, sorry, x-axis, which is 0. And then we know we're extending from 0 to 10 because they say that the h is limited between 0 and 10. So we move on to our volume formula. Normally, our volume formula for this method is pi big R squared. But for us, we're going to use h. Now, to add to the complexity of this problem, we can't enter this in our calculator. This is a non-calculator, so we have to actually work all this out by hand. You may be thinking, oh, maybe I got to go through substitution, but I wouldn't do that because this is only a degree 2. I know it's a little tedious, but it's not too bad. You just have to FOIL all of it out, and it's rely on power rule. So you're going to FOIL everything out, rely on power rule. You only want to explore use substitution if your exponent is either too high or not manageable. Like if it's degree 3, degree 4, or it's a square root or cube root, then you want to explore the other options. But with a degree 2, that's within our capability to just work it out by hand, expand everything out. So first, I'm going to FOIL all this out. So not only is the parentheses getting squared, the 20 is also getting squared. So keep that in mind. So I'm just going to wait till the end to worry about that 400. I'm just going to do power rule for each of my terms. Every term will rise up 1 degree. Again, the nice thing is don't worry about cleaning anything up. Just leave your answer as big of a mess as you like, and they'll have to give you full credit. So that's the nice thing about non-calculator. You don't have to clean anything up. And the nice thing is the 0 is going to wipe everything out still. So, and then don't forget about the pi at the end. This is how I would leave it. You can do other variations of this, but I would just strongly suggest against trying to clean all that up. Then you're spending all this time trying to clean up your answer when you would already earn full credit, and you're taking time away from working on another problem, since you have such limited time on your AP exam. Okay. Any questions with part B? That's a really challenging part of this problem. Part C. Anybody still need part B? Okay. Part C. The funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So we really need to kind of pay attention to these keywords there. If you see with respect to time, that should be a big indication that this is probably going to be related rates. And based off of what I've seen recently, I think we just need potentially more practice with related rates, or just recognizing what needs to happen. The good news with related rates is that your derivative should be easy. It should all just be power rule. Shouldn't be anything more than power rule usually. The challenging thing is remembering that every derivative is going to have a time component. So if there's a v, then you'll see a dv dt. If there is an m, there'll be a dm dt. If there's an r, there'll be a dr dt. If there's an h, then a dh dt will show up. They're not going to say use related rates. They're going to use, they'll say with respect to time. So whenever you see that, and they give you all this information about the rate of change of certain variables, those are clues and hints that we should be relying on related rates. Okay, so we're going to start off with our equation, get it ready for derivative, and then find the derivative, and along the way, your dr dt will show up, and so will your dh dt. All right, so let's try those steps. Before I find the derivative, I'm going to make it a little bit easier on myself where I don't have to deal with the parentheses. So I'm going to distribute that 1/20th through. That way it just feels like nice independent terms, and I can just find the derivative of each variable without looking at the set of parentheses. Okay, so remember, if you're doing related rates, and if it says with respect to time, every variable is going to have a time component show up. So r becomes what? The RDT. What happens to 3/20th? Becomes what? Constant goes to a 0. Okay. Do power rule for this. Bring down the 2, subtract 1 from the exponent. So in this case, our derivative, our h, is going to stay, but don't forget what at the end? The dt, yeah. Yeah. This seems to be the thing that I see students miss the most. Sometimes students will remember that, oh, I got to do dr dt, but forget, oh, I need to, after I find the derivative of that variable, I also need to attach a d over dt for that variable as well. Okay, so that's a hard part. Trying to get to that derivative now, you're just putting in the information they give you and trying to solve for your missing variable. If you're having trouble with units of measure, look at your variables in play here. H is in terms of inches, time is in terms of seconds. So then just put those units over each other. Okay, let's go to page 38. This one should be more straightforward. So the hint is chain rule, quotient rule, and then use substitution. So see if you can work through those steps there. So page 38, next one. I think we would love to see a problem like this on the AP exam. This is so straightforward. You can earn a lot of points with being able to just go through each of the steps. Any questions? Okay, so hopefully you guys are spending time kind of chipping away at these FRQs. You know, this week we've only been able to in class maybe just do like 2 FRQs, um, but if you haven't, then hopefully you can do some catch up this weekend if you have time. But next week, I know a lot of students will be in and out of the classroom, but I'm just going to kind of pace us through packet 6. I'll pick out problems from those selected pages. And then you can turn in your packets 5 and 6 anytime. There's no late penalty if you turn in after the 9th, but ideally, if you can get most, if not all of it done by the 9th, then you're taking full advantage of, you know, seeing all these problems before the AP exam. Now, if you look in your packet, I purposely left off the 2024 FRQs because I wanted to give that to you next Friday. So you can have like a really recent one as a mock FRQ if you want to do it over the weekend. It's not required, but I'll put together the 2024 FRQ, the blank sheets, as well as the key, so that if you choose to, you can kind of have that as your last set of problems to do over the weekend. In addition to, you have access to 3 years worth of more recent multiple choice tests in AP Classroom. So just additional resources for you to have next weekend leading up to your AP exam. Okay. All right, come get your phones.